नमस्ते दोस्तों, आपका स्वागत है मेरे चैनल पर। इसे सब्सक्राइब करें और घंटी आइकन दबाएं।
66 million years ago, a single rock from space slammed into our planet, immediately erasing the most dominant species on Earth. The geological record makes one thing very clear. Earth is not a permanent sanctuary. Over a long enough timeline, staying here guarantees human extinction. But our local options are severely limited. Our closest neighbor, Venus, has surface temperatures hot enough to melt lead and clouds made of sulfuric acid. Jupiter and Saturn are massive gas giants without a solid surface to stand on. That leaves Mars. Even though it sits an average of 140 million miles away, its 24-and-a-half-hour day, solid ground, and vital reserves of water ice make it the only realistic candidate for human expansion. Arriving there, however, means stepping into an endless, desolate desert, tinted rust red by iron oxide dust. This data comparison shows the immediate threat. Mars' atmosphere is a fraction of a percent as thick as Earth's, and mostly carbon dioxide. Furthermore, temperatures plunge to negative 125 degrees Celsius, and without a magnetic field, cosmic radiation continuously hammers the surface. Humanity's best hope for a second home is a planet that would leave an unprotected person unconscious in 15 seconds. Moving an entire civilization requires a brute force approach to physics. Elon Musk and his company SpaceX have set a specific target, a self-sustaining city of 1 million people on the Martian surface. For decades, this kind of logistics was completely stalled by the extreme cost of building rockets that fall into the ocean after a single use. The Starship system bypasses that financial wall. It is designed to be fully reusable, capable of hauling massive payloads of up to 150 metric tons into orbit, landing and flying again. Because Earth and Mars orbit the Sun at different speeds, the planets only align every 26 months. The transit takes up to 9 months, making the earliest missions essentially one-way trips. With launch costs falling and payload capacity rising, the logistics of a Martian city have moved into the realm of active engineering. Initial crews will survive inside pressurized pods sent from Earth, but a permanent colony cannot rely on a supply chain spanning millions of miles. The solution is in situ resource utilization, using local materials to survive. This cross-section shows automated 3D printers using the iron-rich Martian soil to build habitats directly into the ground, well before humans even arrive. Going just a few meters beneath the surface allows the thick soil to absorb the incoming solar radiation and insulate the colony against the extreme temperature swings above. Further down, automated drills will tap into massive underground deposits of ice, melting it and pumping liquid water directly into the base. Subsurface ice is a versatile resource. Beyond hydration, it provides the chemical components for breathable oxygen and the propellant needed to launch return missions back to Earth. Even with water and air, the colonists still have to eat, and they cannot simply plant seeds in the ground because Martian soil contains toxic chemicals known as perchlorates. Instead, they will rely on aeroponics and hydroponics, growing crops in climate-controlled domes without dirt, using nutrient-rich water and artificial LED sunlight. Perfecting this kind of closed-loop agriculture cuts the final cord to Earth, making the settlement truly self-sustaining. Once basic survival is secured, the objective shifts toward terraforming, the active process of thickening the atmosphere and heating the planet to mimic Earth. Scientists have calculated methods to trigger a controlled greenhouse effect. These range from constructing chemical factories that pump gases into the air to detonating nuclear devices over the poles. This model highlights another viable approach, positioning massive mirrors in orbit. These would act like magnifying glasses, focusing concentrated solar energy onto the polar ice caps to melt them and release vast amounts of trapped carbon dioxide. This is a multi-generational legacy project. The first pioneers will start a process that their descendants will spend centuries finishing. As the population grows, they face complex questions of governance. Under the current Outer Space Treaty, no single nation can claim sovereignty over another planet. But the real divergence will be biological. Because Mars has only 38% of Earth's gravity, children born there will develop differently. Over a few generations, their bone structures and muscles will adapt, creating the very first branch of Martian humans. If this timeline sounds overly ambitious, consider our history. Just 66 years separated the Wright brothers' first powered flight from the Apollo 11 moon landing. Today, as SpaceX iterates on Starship prototypes and NASA analyzes Martian soil samples, we are witnessing the transition from speculative science to active development. Leaving Earth follows the same arc as our move out of Africa. Looking up at the red dot in the night sky is no longer just an active observation, but a look at where our descendants will build.
Like, comment and subscribe my channel.